My name is Stephen Gottlieb, and I made up the linear algebra video. At this point, I would just love for you to sit back and view a sample demonstration. I'm going to show you how to multiply two matrices. But first, we need to go over what the dot product is. Suppose you have this column of numbers. 3, 1, -2, -4. Now I'm going to dot this with the following. -3, 4, 5, -1. Now the dot product is very, very simple. You multiply the first numbers, you get -9. Plus, you multiply the second numbers, you get 4. Plus, you multiply the third numbers, you get what you get, -10. Multiply the fourth and last numbers, you get +4. And then you add these. And you'll get -11 if I didn't make a silly mistake. Okay, the dot product is very, very simple. You have 0, 1, 2, -3. Let's even get rid of the 0. There can only be 3 numbers. And you dot it with, now this has to have the same number of numbers. You multiply those numbers, you get 4. You multiply those numbers, you get -8. Adding a -8. Well, there's a rule that says you can change both of those. It's the same as taking away 8, +8, and you don't even have to write the positive. That is the same as taking away 8. And those numbers add up to 0, multiply out to 0. And if you add these 3 numbers, you get -4. And that's the answer. The dot product of this column matrix by this column matrix is -4. Now, what if it's a column by a row? What if you have, or a row by a column? You have 3, 1, 2, and you want to dot it with 1, 2, 3. That's the first entry, the second, the third, the first, the second, the third. You multiply the first plus multiply the second plus the result of multiplying the third. Multiply those 2, you get 3 plus. Multiply those 2, you get 2 plus. Multiply those 2, you get 6. You add them up, looks like 11. Okay. Now, the only concern I have with doing it the way I just did is the following. It's very simple to make a silly mistake. See, here, the numbers were straight across. The numbers were straight across. But here they're not. You might, and making this silly mistake that I'm going to make, it doesn't mean you don't understand it. Doesn't mean you're not good at this. It means you're making silly mistakes. You may multiply those 2. Now, maybe if you draw the arrows, you wouldn't make the mistake I'm doing. But if you multiply those 2, and then you multiply these 2, and then by mistake, instead of doing the 2 with the 3, you do the 2 with the 2. And of course, then you get the wrong answer. I mean, if the first 2 numbers are the same, but you're adding 6 up here and 4 down there, you're not going to get the same answer. Get 9, which is wrong. So, what might you do? Me, I would write this vertically, 3, 1, 2, dotted with 1, 2, 3. Now, it's like the first ones. You multiply 3. You multiply 2. You multiply 6. You add them up, and you get 11, the correct answer. So when you multiply a row by a column, my advice would be to do what's called the transpose. Take the transpose. That is, just write it as a column. Write it as a column. And don't do anything to this. And then they're lined up. They're lined up. And this dot product procedure is exactly what it takes to multiply matrices. In the matrices, oh, let's scratch that. Okay, so let's multiply these two matrices. 3, 0, 1, negative 1, 2, 3, 1, negative 1, 0. Let's multiply this matrix by 1, 2, 3, 0, 3, 1, and that's it. Now, when you multiply two matrices, you get a matrix. Now, just like when you're multiplying polynomials, 3x plus 4, 3x squared plus 4x minus 2 times 2x plus 3. You multiply the first by the first by the second, and if there is, a first by the third. But there is none. So then you go to the second. You do the second times the first, the second times the second, and nope, there's no second times the third. That means we're done with the second. Then you do the third with the first, the third with the second, and by now you know there's no third with the third. It's a very similar thing with matrices. You are going to dot row 1. You're always going to dot rows from the left matrix with columns from the second matrix. You're going to do row 1 with column 1, row 1 dotted with column 2, row 1 dotted with column 3, row 1 dotted with column 4, etc. If there are that number of columns. Now row 1 is 3, 0, 1. But again, write it as a column. And column 1 is 1, 2, 3. Dotted with 1, 2, 3. So it's 3 plus 0 plus 3. 3 plus 0 plus 3 is 6. And where do I put the 6 up here? In row 1, column 1. Row 1, column 1. 6. Then I do row 1, I dot row 1 with column 2. Well, this is row 1 written as a column. Row 1, I write it vertically with column 2. 0, 3, 1. 0, 3, 1. And this is going to be 0 plus 0 plus 1. Which of course is 1. In row 1, column 2, I put a 1. Put a 1. Then I attempt to do row 1 dotted with column 2. Row 1 is from the left matrix, but write it vertically. And I dot it with column 3. Well, this was column 1. This is column 2. There is no columns 3. Okay, so I can't do that one. So what do I do now? I go on to row 2. I do row 2 with column 1. I do row 2 with column 2. So let's do that. Row 2 is negative 1, 2, 3. But we write it vertically so we don't make any silly mistakes. Row 2. Negative 1, 2, 3. And I dotted at the top with column 1. Column 1 is 1, 2, 3. 1, 2, 3. And I get negative 1 plus 4 plus 9. Which is 12. Where do I put the 12? In row 2, column 1. Okay, so it is a row 2, column 1, right here. Row 2, column 1. Then I do row 2, I dotted with column 2. I already wrote down row 2. Now in the second matrix, I write down column 2. Looks like I'm going to get 9. Get 0 plus 6 plus 3. 9. Where do I put the 9? In row 2, column 2. Row 2 is across here. Column 2 is up and down. Right there. This dot is in row 2, column 2. And I put 9. Okay. Now, you can't dot row 2 with column 3. I mean, there's a row 2. It's right there. It's this row. Column 1, column 2, no column 3. So we're done with row 2. So we go to row 3. If there is, in fact, a row 3. And I dotted with column 1 and column 2. Row 3 is this row. 1, negative 1, 0. Then I write it vertically. And I dot this with column 1, which is 1, 2, 3. 1, 2, 3. Looks like we're going to get a negative 1 this time. Because here I have 1, 1. And I'm taking away 2 1s, which is negative 1. Where do I put this? In row 3, column 1. I need a third row. Column 1 is right there in the third row. So I put negative 1. Then I do row 3. Write it down vertically. And I multiply it by column 2. 0, 3, 1. Column 1. Column 2. 0, 3, 1. I get 0 and 0. So the answer is going to be whatever negative 1 times 3 is. Negative 3. Where do I put the negative 3? In row 3, column 2. Row 3, column 2. Right there. Okay, I can do row 3 with column 3 because there's no column 3 in this second matrix. First matrix, second matrix. So then I go on to row 4. And I'll dot it with column 1. Oh, row 4. There is no row 4. There's a row 1. There's a row 2. There's a row 3. There's no row 4. Oops, that means I'm done. The only change I make is I'll move this bracket over. And I will say that this matrix times that matrix equals this matrix. So all it is the dot product many, many times. You do each row in this matrix, which each column in that matrix. Row 1, column 1, right there. Dot row 1, column 2, right there. Then attempt to do row 1. Oh, no column 3. So we're done with row 1. Row 2, column 1, right there. Row 2, column 2, right there. Row 2, oh, no column 3. I'm done with row 2. Go on to row 3. Row 3, column 1, right there. Dot row 3 with column 2, right there. Row 3, no column 3. So we're done with row 3. Then you go on to row 4. And you say, oh, there is no row 4. That's when you say done. I mean, what are you going to do? Dot row 5 with column 1? There's no more rows to dot. You dotted every row here with every column there. And you put the answers in the appropriate places. This completes my sample demonstration. Hope you learned the dot product and how to use the dot product to multiply any two matrices. I want to thank you for watching my video to the very end, and most of all, I wish you great success in your linear algebra course. Thank you. Have a great day.